about metal fabrication specifically in facilities maintenance. Metal fabrication can mean different things to different people, but basically, sort of the universal definition, if you will, for metal fabrication is a process of creating something out of metal. The fabrication process will usually consist of planning, designing, measuring, cutting, bending, drilling, grinding, and welding metal pieces together to complete a finished product that serves a specific valuable purpose for your facility, either your internal customer or your external customer, and whether that purpose is to help employees work more productively or safely, or increase your output and your throughput for your product line. So here's the basic metal fabrication process. Again, what is the need? What are we trying to accomplish? And then once you answer that question, you go on to the design phase. It could be an AutoCAD program that you utilize to draw plans. You can even use a program like Fusion 360 or SolidWorks to create a three-dimensional model. Or it could be a hand drawing. You could simple, pen and paper hand sketch. Or it could be, pencil and paper, T-square, your triangles, your drafting, ellipse templates. Ideally, the more precise and organized and exact and clear your design is, the better chance you have of getting your design approved, the better chance of everyone clearly understanding exactly how the finished product will look and function. So then you go on to create your bill of materials and your cut list. So your bill of materials is going to list all your materials, parts, part numbers, description, quantities. And then your cut list is usually a separate list, and that's for your metal fabricator, your welder, your fab shop, or if you're a shop where your facilities maintenance technician is also your welder and your fabricator, like in my experience, then he creates a cut list of, okay, I need 10 feet of 2-inch square tubing, 4 pieces of that. I need 2 pieces of 1/4-inch thick mild carbon steel plate, that are 2 feet by 2 feet or whatever. Once you get the bill of materials and the cut list, then you factor in, okay, how much time is this going to take us to fabricate and assemble, paint, install, etc. And of course, part of your bill of materials is the cost. How much all of these components and parts cost, and what would be the total for all of those parts and components. Then you would submit all of that to get approval from management. If it's not approved, you stop and then you ask, okay, do we want to modify the design, try to find less expensive parts and materials, and then resubmit? If the answer is yes, then you go back to the beginning and adjust your design, adjust your bill of materials. If the answer is no, it's just there's no way else to build this product, or we don't need it as badly as we thought, or the budget doesn't allow it this year, maybe next year, then you stop there. However, if your design and bill of materials and cut list is approved, then you complete the fabrication process. Go ahead and order materials. You can either have your local metal shop cut everything to size for you, which saves a lot of time and labor, or you can buy full sticks and cut everything to size in your shop. Just make sure you have the tools and space to do that. And then, you perform your welding, your, drilling holes, bolting things together, painting, etc. And then you end up with a finished product that you install or give to your external or internal customer. So here's an example on the left side of an AutoCAD drawing, an orthographic representation of a rotating build stand. And this is just an example. But basically, you're going to show, the front, back, top, sides, specific details, measurements, specific angles, And so that gives everybody a very clear representation in three-dimensional form in a multi-view drawing, what is the end product going to look like? And then that'll also help you figure out your fabrication process as to how am I going to weld this together, what's going to be bolted, what's going to be welded, etc. And then do you have the floor space for this item, etc. On the right-hand side is a hand pencil drawing or mechanical manual drawing. So this was done with, you tape a piece of paper down, you use a T-square and your 30-60 degree triangle, your 45-degree triangle, and you draw it out by hand. And then I scanned it into the computer and added the shading. That was a belt type oil skimmer that I designed and built a few years back before I had access to an AutoCAD program. So that's two ways you can go about creating your design. But again, you can see if you have a very clear design, then it makes it easier to get it approved and everybody can understand it right away. So here's an example of bill of materials. Again, your bill of materials might look a little bit different. This is a template you can find online. So you're going to list, what are all the components we need, a brief description of what those components are. You might need 10 quarter 20 grade 8 bolts, right? So that would be on here, and the cost per unit. And then down at the very bottom, you have total cost. Then usually there'd be another listing for extended cost where you might want to add in tax or shipping, etc. Sometimes that's not necessary. On the right-hand side, we have an example of a cut list. And again, this is a generic example. So you would say, okay, part number 1 is an aluminum sheet. Here's the dimensions I need to cut that sheet to. I only need 1 sheet. Part number 2 is also an aluminum sheet. Here's the dimensions, but I need 3 of those sheets. Thank you for watching. Please like, share, subscribe. Leave me a comment for future video topics you would like me to cover.